Hello, this video is for the assignment that was given. This is P1H Ch7 section 4, problems 14 through 17. So we start with number 14. They're asking us to use information from the example problem number 2. And so the satellite orbits at 225 kilometers above the Earth. Earth mass is 5.97 E24 kilograms. Radius is 6.38 E6 meters. And so the problem says, let's move the orbit another 24 kilometers out. So the new orbit is the old orbit plus this new movement, plus the radius of the Earth. Because remember, we're measuring from center to center. So our radius then is 6.629 E6 meters, and never round until you get to the end of the problem. So the question part A is, what is the velocity of the satellite? Here's your formula. V is equal to the square root of the quantity g m sub e over r, where g is given as 6.67 e negative 11 Newton meter squared over kilogram squared. Pardon. So you do your substitutions, take the square root, and use 3 significant digits for this answer. So 7.75 E3 meters per second. And this speed is slower than before. Why? Because r is greater. If the numerator stays the same but r gets larger, then that quantity is smaller. So that's the answer for number 14. Number 15, this was funny. No matter how you say this, it's going to come out either Uranus or Uranus, and neither of those are very respectful for this unit. So I decided, you know what, this would be funny, but I'm not really going to call it this. It'd be Uranus, and so it's better than Uranus. Okay, it has 27 moons. It was discovered by Herschel in 1781. It's the 7th planet from the Sun, and Miranda is one of its moons. It has an orbital radius of 1.29 E8 meters. It has a mass of 6.68 E25 kilograms. And what is the orbital speed of Miranda? Put the formula there. By the way, instead of doing all of this, use the store facility on your calculator. So you'd take 6.67 E negative 11 and you'd store it in alpha G, and 6.68 E25, and you store it alpha M, and 1.29 E8, and you store it as alpha R. And so that makes everything so much easier. Use 3 significant digits in the answer, and so this rounds up 6.70 E3 meters per second. Now the next part of the problem is, how many days does it take to complete an orbit? Alright, so again, here's your formula. T is equal to 2 pi square root of r cubed over m of Uranus. Use store facility on your calculator, and I got T is equal to 1.209 E5 seconds. Now since there's 86,400 seconds in a day, you divide T by 86,400 and this becomes days. So I get 1.4 days. Number 16, calculate the speed required for a satellite to orbit the Earth at an altitude of 150 kilometers. Okay, let's see. If the radius of the Earth is 6.38 E6 meters, then I have to add that altitude. So my new radius for the orbit is 6.53 E6. Use this formula, do your substitution and store again, and I get 7.81 E3 meters per second. Okay? All right. Let's see what we have now. That's 15 and 16. 16 part B is how long in minutes and seconds. So T is, use your formula, 2 pi r cubed over g m sub e. Do r cubed first, then divide by g times m. Use parentheses on those. And get that answer, take the square root, multiply by 2 pi. You should get 5.2541 E3 seconds. Divide by using 60 seconds is a minute. And this becomes 8.75685 E1 minutes. So you want to take the whole number of minutes out, since that's E1. That's 87 minutes. The decimal part is going to be 0.5685. What you do, you subtract 87 from that number to get your decimal part. Multiply now by 60 seconds per minute, and you get 34.11 seconds. So the answer is 87 minutes 34 seconds. Okay? 87 minutes 34 seconds. Now the last problem is the challenge problem. It's about Mercury and the speed of the satellite. They want to know the speed of the satellite orbiting at 260 kilometers above Mercury. And to do that, use the formula V equals gm of Mercury over r, and I use the store facility. Remember, you have to add the radius plus the altitude to get the new radius of the orbit. And I get 2.855 E3 meters per second, which in 3 sig fig becomes 2.86 E3 meters per second. What is the period of the satellite? Use the formula. T was 2 pi square root of r cubed over gm. Again, using store facility, I got 5.94 E3 seconds. And hold a second. All right. So since this gives me 5.94 seconds, and the question was never said to us to change this to hours, I'm not going to convert it. I'm going to take this as the answer, because the question was not asked. Change it to hours. Okay, so that's it. And let's see, I may have another lesson for you in an hour. We'll see. Bye.